Hey guys, I'm in the shop here and I was just getting ready to run some face frame stock. And I thought I'd take a moment here to do a quick video here of my setup that I set up to do face frame stock on my Powermatic 27 Super shaper. It's the same thing as a Powermatic number 27, but the difference is it has the 30 by 40 table versus the 27 by 28. So it's still the same thing as a 27, but like I said, it's just got the larger table. So they typically were called a 27 Super or a 27S. They're quite popular as well. So anyways, what I have set up here is a Byrd tooling straight cutter. This is what they call a Shelix cutter head. It's basically a machined head that accepts these 14 by 14 millimeter square inserts that you can rotate 4 times to keep a sharp edge. And they're wrapped in a spiral and they're slightly skewed at a slight angle. And the idea is that you get more of a skewing action versus a straight knife into the edge of your wood or face if it's a planer. Byrd also makes planer heads for a lot of the common planers out there, and this is basically the exact same thing except it's designed for a spindle, and you can get these in different diameters and different bore sizes. This one happens to be a 3 3/4 inch diameter, 1 1/4 inch bore, because the Powermatic I have here has 1 1/4 inch spindle. So anyways, the way this works is this stainless steel 1/4 inch plate is actually, or flat stock, is actually an auxiliary fence. And the way this works is I'd be feeding the stock in from this direction like this here with the power feed, and I'll show you that here very shortly. But the idea behind the system is that I'll have a consistent width because I'm running the piece between an auxiliary fence and the cutter head. Essentially, it's the exact same thing if you were to lay a planer on its side and have the planer head running up and down versus or running vertically versus horizontally. So with that being said, this is the exact same principle as a planer. This would be your planer bed, this would be your cutter head, and this would be your pressure bars. There's no feed rolls here obviously because I'm feeding it the other direction, but this is the exact same principle. And the nice thing about this is that by running it this way here, running off an auxiliary fence, I'm sandwiching wood between the cutter head and the auxiliary fence, which allows me a nice, even, consistent width. So once I've run one side, just runs through like this here, take it out, and I got all my pieces run, I take this fence and I move it into its final dimension. I typically try to keep it a 1/16 of an inch. Right now I've got 2 1/16. This needs to finish at 2, so what I'll do is I'll move this fence in 1/16 of an inch, run a scrap piece through, check it with the calipers. If it's within that 10 thousandths, I let it go, and then I run the other edge through. And like I said, the whole idea of this system is you have a consistent width. If I were to use just these fences here, it'd be like a joiner. And the problem with the joiner is that there's really no reference to the other edge of the board. So you do run the risk of running a taper. I have in the past actually run the first pass against this fence, and then the cleaning pass and the final dimensioning pass against this fence. But I found that if you don't have these in perfect alignment and you don't take the time to shim them, then you'll have snipes and dips. So I just run everything across this fence. It's worked really well. I've been doing this for the last probably 3 years, if not more. I used to run to the planer, but I still have a straight knife planer yet, so you actually have to look at your grain before you run it through. The nice thing about the Byrd Shelix head, it really doesn't matter which way you run it through. The last job I did, I ran some maple for a vanity, and I didn't look at which way I ran it, and it was chip free. It was nice and even and clean. So this particular setup, I have the spindle running at 6,650 RPMs and the feed rate running at 26 feet per minute. Okay, so you might be wondering how I get 6,650 RPMs out of a 2-speed shaper that's rated for 7 and 10,000 spindle speeds. When I first got the shaper, it was bare. It did not have an electric motor of any kind, didn't have any controls, so basically when I bought it, I needed to basically furnish the electrics. And I originally had a cheap magnetic starter and a 3-horse single-phase motor mounted in the back, and then about a few years later I had gotten the option to pick up this Ballard frequency drive from my workplace because they were throwing it out because it was 230 volt 3-phase versus 460. And they had no use for it. It had been rebuilt, and they just said, if you want it, take it, here it is. So I took that, and with that being said, I had this bright idea that I wanted to take my main Powermatic 27 Super and turn it into a variable speed shaper. So what I did then was I had purchased a brand new 5 horsepower 3-phase Ballard motor, 3450 RPM, put that in the back, and hooked up this variable frequency drive. Now the one thing I'll tell you, and I want to kind of keep it real short in the subject because it's not really about the variable frequency drive, but if you take a variable frequency drive and hook it up to a 3-phase motor, typically in the 1 to 2 horsepower range, if you get a variable frequency drive that's rated for 1 or 2 horsepower, they're just fine. You run them on 230 volts single phase if that's what the input power is, and they got their full capability and output. But when you get into your larger horsepower, say 3 horsepower and over, a lot of manufacturers derate the output horsepower capability or current capability. Reason being is that the way a variable frequency drive works, and again I don't want to spend a lot of time on this, but the way it works is it takes single phase or 3-phase AC voltage on the input side, converts it to a DC voltage that's rectified back into an AC voltage that has a different sine wave that allows you to basically change the frequency, which allows you to change the RPM, also basically change the maximum output amperage or available amperage, maximum current, however you want to talk, label it, I guess. But there's a lot of features for a variable frequency drive. Now this drive is actually a dinosaur. This drive is 20 years old plus. You still have to set all the settings to potentiometers down on a cover below, versus the new ones pretty much have a keypad now where you just go into different settings and parameters. Anyways, getting back to as far as derating, almost any 230 volt variable frequency drive can run on single phase. The problem is that once you get into your larger horsepower, say 3 horsepower and bigger, most manufacturers recommend that you derate the drive. So in a perfect world, I think Ballard derates, I think 30%, maybe it's 50. I think most manufacturers are 50%. So if you have a 5 horsepower 3-phase motor that you want to run, in reality you need a minimum of a 7.5, possibly a 10 horsepower VFD. Reason being is on 230 volts, let's use 240 volts for example. On a 240 volt VFD, with a typical input of 240 volts 3-phase, each leg has 80 volts going to the drive. On 240 single-phase input, you're actually inputting 120 volts into each leg, and nothing on the third. I think Ballard 15Hs, maybe I'm not sure if it's I've got a couple Ballard 15Hs, but I think they actually run a jumper from leg 2 to leg 3 or from L2 to L3 as well. But essentially, it's not getting the proper voltage, so therefore it's not as efficient. Therefore, it doesn't really have the full capabilities. I've been told that you can use the same horsepower drive if the motor is not fully loaded at all times. If it maybe peaks once in a while, it's okay. But if it's, for example, this drive here is capable of putting out 15 amps, 230 volt 3-phase, with 230 volts 3-phase going into it, you'll get a maximum output of 15 amps on a variable frequency. The motor I've got underneath there is good for I think 12 or 13 amps on 230 volts, and what the district office had told me is that I should be okay with that, providing I'm not constantly pulling that full load amps on the motor and the drive. If I was constantly pulling the say 12, 13, 14 amps in that motor and that was its full duty cycle, I really need to go to the next size drive up. But because the motor sits idle most of the time, and the only time it peaks at it's probably 12, 13 amps, or maybe a little more, is when I'm running end grain on raised panels, but they felt I'd be okay with this. So the one thing to keep in mind is if you have a heavy, fully loaded motor, 3-phase, and you want to run it off single phase with a variable frequency drive, you need to make sure that your drive is oversized enough to maintain that. Originally at one time I looked at putting a variable frequency drive on my dust collector along with a couple sensors to speed up or slow down the blower depending on the filter bags. And what stopped me was the cost of the VFD. I had to go to a 10 horsepower VFD, and that VFD was like $4,000, and I said, absolutely no way, ain't ever going to happen. Not now anyways. But anyways, I just wanted to give you a brief update. The one other thing with that to really be careful with, if you get an old motor, oh boy, something that's not what they call inverter rated, it's something that's got some age on it, be very careful with running a VFD on that, because what will happen is the insulation and the varnish that the manufacturers used, say 20 years ago on these motors, wasn't as strong, and so what will happen is there's voltage spikes in the end turns of the windings, and what will happen is that voltage spike might be as high as 1,000 volts possibly, and what it does is it'll actually burn through the varnish or the insulation of the windings and it'll short out. So that's why a lot of manufacturers now have what they call inverter duty motors, because it's got a special varnish on the windings themselves to keep them from shorting out. So just a little tip I thought I'd share with you. Alright, let's make some sawdust here. Okay, so what I have here is a piece of 2 1/8-inch face frame stock that I'm going to run one edge on. I'm going to run all pieces, then I'm going to flip them end for end and run the opposite edge. This piece here, can't see it too well. You can kind of see it's got some pretty nasty saw curves from the table saw. There you can kind of see some as well. I'm going to try and do this one-handed here. So I'm going to run the power feed on number 2. That's 26 feet per minute. That's only 13. So we're going to run on 26. Over. Definitely can live with that. So now I'm going to run the opposite side. This side here I already ran. This side still has saw curves. So I'm going to put the side I ran against the stainless steel plate. that's how this is run here. And some equipment turned on. So anyways, yeah, that's how that works, and hopefully you guys enjoyed it. And any questions, let me know. Otherwise, hopefully have some more videos coming up in the future, and we'll just keep going from there. Alright, thanks for watching.